My good friends, I apologize that I'm only able to write to you in such a time of need. But you see, I've landed myself in a great deal of trouble, and I need your help to get me out. Some parties have seen my less than wholesome activities last week, and they were far from forgiving. Meet me on Monday at 1 p.m. and Thursday at 4 p.m. on Zoom. Thank you. Oh, they're here! Let's take a moment to consider how our computer stores variables in memory. We can imagine our memory as a continuous line of slots, each with their own associated number, indicating which slot it is. And in this, we can store our primitives. We can consider another area of our memory to store references, which we'll call the stack and the heap. This is not the full idea of stack and heap. That's a rather complicated concept. We'll do a simplified version for this tutorial, where we will think of it as values and references. Our references can point to a value, and that value can change. It's mutable, and the reference will stay the same. We can also reference multiple values from one reference, and that's called an array. When we create an array, we allocate a certain number of slots from values to a certain reference. Here, we allocate 8 slots to a reference called array_of_int, and in those slots, we fill it with ints. The blue array, we will call it, starts at index 1, and when we want to resize it, we have to create a new array, starting at a new memory area, and we have to fill it by copying the values from the first array. This is a time-consuming and tedious process, and we have 2 arrays existing in the memory at the same time. When we want to swap it over and make the previous array into the new array, we don't actually change the array. We rather just change the reference. We change the blue array to be pointing to the newly created array, and then we can discard the red array as it no longer exists. It's pointing to the same thing. Now, garbage collection will take care of the old values that we've already copied over and are no longer being referenced by anything, and we have a resized array. But notice that we created a whole new array in memory. It has nothing to do with the original array we created. We copied over all the values, added our new value, changed the size, and then changed the reference. We didn't actually resize the original array. To have a resizable data type, we have to consider something a little bit differently. And for that, we're not going to think about our memory anymore in values and references. Rather, let's just think about memory as storing objects. We have a certain amount of slots which can be occupied by any kind of object that is defined in a .java file. Objects can contain whatever fields we want, primitives or references to other objects. Here, we will consider an object which is able to reference another object from itself. So how can we do that? Well, what if we had an object which actually references another object of the same type, and then we just have a chain of these references which lead us to the next value? Remember, in memory, we don't know what we're looking at unless we have a reference. So let's say we have a reference to a node at 56. Node at 56 stores a reference to another node at 57 and a value. And that reference is key, because that reference points us to the next node in the list. As we travel through our list, we can see that the existence of the pointer reveals to us the next nodes. And as we follow through our list, and we take our time to iterate through and access each node, noting that it actually takes a long time to traverse through this list. So the more nodes we have, the longer it'll take to get to the last one. We can see that each node indeed has its own pointer and value. And as we follow through, as we cascade down the list through the pointers, we can see what happens when we reach the end of our list. At the end of our list, the last node will point to null, because there is no next element. And this is one of the keys of the linked list. It's easy to add a node. All we have to do is change that null to a new reference, and suddenly, we're able to be transported to our next node, as if it was in the list the entire time. This creation of new references and change of references is the core resizability and modifiability of a linked list. It's what gives it its advantage over an array. So now if we follow through our list, we can see our previous nodes were unchanged from this operation. And as we flow through our memory to get to the next node, we can see that the creation of the new pointer has revealed to us that our list is expanded by 1. And now if we check the value and the reference of this node, we can see that since it points to null, it's at the end of our list. And now we've got a linked list that's modified. This is the core useful feature of a linked list and why we create them, and its advantage over an array. Hello, fellas. Hopefully you can hear me now. I'm just gonna double check you can. And you can see me now, I think. Just get a confirmation on that. Awesome. Hopefully the overdone animation makes up for the atrocity that was last tutorial, and we can get started on working through linked lists. So hopefully that made the kind of concept of what we're going through more clear. Now that we have the concept down, we're going to go through a bit of the implementation and see if we can actually craft a linked list of our own. So as usual, we have a GitHub page for today's tutorial, which I will pull up right now and I will send to you guys. Let's just transition us to our computer. Give me a sec while I just get the link. Alright, and I'll send that to the chat. Perfect. So as you guys can clone the repository, we'll see if we can implement a linked list. Let me know if any of you guys haven't cloned. If you did go to last tutorial, just reset. You can do it by VCS, git. Oh, you're new. Oh yeah, sure. I'll show you. So if you're using IntelliJ to get a project from GitHub, you can go VCS at the top here. My webcam is covering it up. Give me a second. So here you go VCS, git, not get from version control, paste your link, clone. That's all you have to do. So if you're in IntelliJ, again, it's VCS, get from version control, paste your link, click clone. If I open up Eclipse, I can show you that one as well. Yeah, just give it a second to open. So here we go, file, import, projects from Git with Smart Import, that's under the Git folder. Next, paste, or not paste your link here, sorry, clone URI, and then paste your link, then next, then finish. Hopefully that should be relatively clear. If not, you can let me know. Okay, well I'll take the lack of answer as a relatively clear thing. And now I'll ask you guys to, if you have the project, scroll down. Yep. You don't download a file. You have to go to your IDE, like I showed. File, import. This is in Eclipse. Project from Git with Smart Import, and then you paste your link. And your IDE, so that's Eclipse or IntelliJ, will handle all of that for you. You don't have to worry about what files. It'll download it for you. You just paste the link into your editor, and then you should get access to the files. All right. Yeah, it shouldn't take too long, and I'll just ask for us to, as a class, work through to make the list. So remember, a list is composed of multiple nodes. And what sometimes gets people about linked lists is figuring out which methods go in the class for the list and which one go into the list node class. So can anybody maybe think of what fields should be put into list node? You're welcome to just come on the mic and say. You don't have to do a hand raise or anything. Yeah, node and next pointer. Yeah, okay, an int. We could do an int, but actually in this case, I'm doing something special. It's called a generic. So do you guys notice how at the top of my class declaration, I have these triangle brackets with an E inside? Does everybody see that? Okay, so can anybody guess what the E is actually doing? I can maybe give you guys a hint. If you go into a different class and you create one of the Java data types, you know how Java has built-in data types for things like array list and linked list and stuff? Like Java has data types like array list string. Yeah, it's saying that E is like a placeholder for whatever data type you want to use. So you can make it a string, you can make it an int, you can make it whatever you want. E is generic. E means that this data type will work on anything you want. It'll work on strings, it'll work on list nodes, it'll work on literally any kind of object in Java because E is a generic thing. It's saying that anytime I write E here, that is going to be replaced with whatever I put into the triangle bracket. So here I could put string, here I could put integer, here I could put boolean, I could put whatever I want here. So why is E instead of object? E is instead of object because if we just put object, we have to do things like instance of, and we have to cast the object, right? But E, like the generic E, lets us specify the object when we create the list of links. So if I make a main method in here, and I'll get rid of this unnecessary bracket, and here I can say list of links string list equals new list of links. Notice how I specified that it takes a string. And that means everywhere in this list of links where there's an E, it is actually replaced with a string. Let's like imagine you control F, control V. And that way I can say list of, or I guess say list dot get, and that will return a string. So I can say like string s. Yeah, and that'll, see that'll, oh, it needs a index. I guess list dot get first. There, so that will return a string automatically. If that kind of makes sense for everyone, what the E does. So the E is a placeholder for any kind of object. So now can anybody guess what kind of fields would go into the list node? You can feel free to say it in the chat or say it with your voice as you wish. Yeah, pointer to the next node, we can do that. So if you, how would you write that in Java code? Like if you were to put a pointer to the next node into Java, how would you do it? Well, I see the lack of response as an indication that I should probably explain it. So yeah, Claris got it, but I'll explain it a bit more. So here I could do a list node, E. E just means it takes the same type as the other list node. And here we can have next, yeah. And what I'm doing here is it's storing this reference. This isn't actually storing a list node object, it's storing the reference to a list node object. Well, it is also storing a list node object, but it's not like this list node has like a recursive amount of list nodes inside. Rather, it's just saying that this one is storing the location of the next node. And then another thing we want to store is the data on the inside. And remember, we're using E as a generic, so we can say E data. Now this list node, again, it stores the pointer to the next node as list node E next, and that stores the location of the next node, and it stores E data, which is the data in the current node, if that is clear to everyone. If there's any question about it, please let me know. No? All right. So yes, we're storing data and we're storing next. So can anybody suppose what code would be put for the constructor? If any of you can write the constructor on your own setup and send it to the chat, I will see if it is a good solution. And I'll give you guys a sec to do that. Remember, it's a really simple setup, because all we need to do is we need to store a piece of data and store a pointer to our next one. Yeah, Zahir's got it. So you do this.next, or this.data is data, and this.next is null. And remember, when you don't have things of multiple types, you don't have to put this, so you could also just say next equals null, but we'll keep the this. So does that make sense to everybody why we do it? We set the data to be what's in the data, and the reason we set it to be null is we're not actually creating the full list yet. We're only creating one of the nodes. And remember, a single node has no associated node necessarily. It can have it as null. That just means it's a list of length 1. So how would we do this next method? Well, when we want to get the next node in the chain, we literally just return next. It's just a getter method for our next list node. So we return next. And this way, it gets whatever node is next in the chain. Now, a setter method, I think we all know. Like, this is really, everybody knows how to make a setter. It's just this dot next equals data. Makes sense. Get data will just return data. These are all really easy methods. Like I could ask you guys to write them, but the amount of time it would take you guys to write it in the chat would probably be too long. And if any of these methods are confusing, I'm happy to answer the questions and explain them in more detail. But at least I'm pretty sure that these are the easier methods of it. Or this dot data equals data. What's that next? Ooh, I made bad variable names here, but Oh no, it's not data equals data. I did make terrible variable names because I called the one above data as well. I'm just setting data and I'm getting data. I just said these were simple and I screwed it up. Anyways, it's set now. So this is the list node. This is literally all the code you need for a list node. And this list node is, since it's generic, this is as good of a list node as you will need basically ever in your time using linked lists in Java. Like, this is the only list node you will ever need probably, unless you do something like a doubly linked list. This is like a singly linked list node, basically done. If there's any questions about it, you're welcome to ask. Yeah, you don't have to put up your hand. You can just turn on your mic. I have my this one full screen, so I can't see the Zoom screen. So yeah, if you wanna ask away, just unmute. You can ask. Sure. Oh, sorry, because I had a bad variable name. It should be like that. Like, yeah, it's just I forgot to call this one next. I called it data because I was hastily writing that, but that should make more sense, right? Hopefully that's quite clear. We've got list node. Now we can do the harder part, which is the actual linked list. And why don't we start with something easy? So what fields do we want to put into the linked list? How do we define? I'm kind of confused why we lead in list nodes. Is this something like we import or a class, or do we need to create it every time in our assignments? Well, if we create a linked list, you can use this linked list in basically any assignment that requires one. This one, line 43 saying illegal modifier. Is that expected? Yeah, right now the code is expected to be quite broken because we haven't actually done anything yet, but it won't be broken later on when we actually write it. And I'm kind of confused why we need list nodes. Like, is this a class we need to import, or is it a class that we need to create every time in our assignments? This is a class which I'm showing you how to write because in your future assignments, you're going to often want to use linked lists, and you're often not going to be allowed to import the Java linked list. So what I'm doing is I'm basically showing you how to write the Java linked list yourself so that you can use this and save yourself a lot of time in the future. Because instead of writing, you're going to have to write a queue, you're going to have to write a stack, you're going to have to write all that stuff. All of those can be implemented with a linked list, and this one is the most robust and like generic one you can write that will apply all the time. So it's just kind of a useful tool to have under your belt. Are we using variants for this list creation? I think you're mixing terminology between languages there. So could you maybe put that into different words? Because I'm pretty sure you're probably using Python terms there, and I'm not quite sure what you mean as variants. Do you mean generics? Because we are using generics. That's where we have an unspecified type. Yeah, we're using generics, which means that like we're not setting a type of the list. We're just using a generic list type. But no, I don't believe we are doing anything by the name of variants at the moment. We're just using a generic. So, going through it there, we have to get all these methods done. Can anybody figure out what kind of field we'd want to have in our linked list? Remember, to have a linked list, the only thing we need to be able to read a linked list is a reference to the first node of the list. So what do you guys think would be a good set of fields to have? First and size. Yeah, that's a solid, yeah, or head and size. That's pretty accurately what we're looking for, yeah. So we can say, private list node E, which because it just follows the same generic head, and we want a private int size. Now there's multiple ways to do size. You could also do size where you calculate it every time you need to get it. So that will work too. You don't actually strictly have to have a field for size, but usually it's better to have it just because it's faster. So those are pretty solid. Now we have a constructor, public list of links. So how do you guys think we would handle this constructor? I'll actually give you guys a hint that there's multiple ways to do the constructor. You can either have a constructor for an empty list, or you can have a constructor for a filled list. And this is the constructor for an empty list. So do we have to put anything into this constructor? Set head to null. Well, head is already null, but we could. Yeah, we can do that. No, because both are already set to null and 0. Yeah, they are. So we don't actually have to do anything, but we could then also say this. Like, we can just say null and 0. They're already set to that, but, just so that we have it clear, it's more easy to read. We don't have to do anything. That's right. So, yeah, so for our isEmpty method now, that's another really easy method. So how would you guys implement an isEmpty method? Check size. Yeah, you can check the size. So we can say return size is 0. And then if we want to make it really good, let's say we don't trust our size counter, we could say return size is 0 or head is null. That's how I would do it, because this way, even if our size counter is wrong, our head being null will still return is empty true. Hopefully that makes sense to everyone. So how would we do get first? It should also be a really easy method to implement. Return the head. Yeah, that's right. Remember, because the head is always the first element in the list. So all we'd have to do is just return the head of the list. And then we have the first element. It's really easy. Like, all these methods are one-liners. They're super simple. But it does get a bit harder. For example, when we return the size, we could return size. But we also might want to calculate the size. So when we calculate the size, we have to iterate through the loop, like a list, and count how many times we hit one of the variables. That's if we modify the list. Really, this was fine though. We can return the size as it is like this. But if you want to make a method where you don't have the size as a field, you could also here, also works if you have a for loop, or a while loop, I guess, loop going through the list and counting how many times, or how many times you need to go to, count the whole list. Both work. This was the faster method, so that works. So how do we get a node from a certain index? What would be the reasoning for not having a field? Just to save a bit of memory by sacrificing time? Yeah, it would be to save a little bit of memory, but also it's just in case you don't trust your counters. Like, let's say that you don't trust that the size variable is going to be consistently kept for whatever reason. If you believe that for some odd reason it's possible to remove or add a node without having the size variable change, then the only way you can really get the size is by counting. It's in a situation like if you're able to replace nodes. For example, if there's a linked list where you're able to access the nodes directly, and you're able to say, like, replace a node at a given index, rather than just getting the value, but if you actually are able to replace the node, then you'll need to count it like that, because otherwise you can't trust the adders and subtractors. Loop through the list until you go by index time, and then return that node. Yeah, that's right. You loop through the list for the amount of times as the index, and then if it goes null, you have to throw an index out of bounds exception. So we'll do that in a second. But let me also just do another note for the size thing. So if you have a system where you can combine lists directly by manipulating nodes, you may not always be able to trust int size. So it just depends on how you write your linked list. There are situations, if you're able to directly manipulate the nodes, where the size won't be trustworthy. So that's why you might want to loop through. But it's rare. Usually size does work. And it's usually the best way to do it. So okay, we can go through get at an index. So to get an index, we should say, for instance, well, first things, we got to go through how to do a list traversal. So can anybody kind of guess at what the code would be to traverse a list? It's okay, you can, if you'd like, you can take your time, or I can go through it. Would you be able to do a for each loop? We won't be able to do a for each loop yet, because we haven't actually implemented the iterable interface. That's something that we can get to probably next tutorial, because it's a bit more advanced. But to do for each, we have to implement a particular interface. So no, what we actually want to do is we want to start out by checking if we can even have the index within our list. So the first thing I would do is say if index is greater than this dot size, yeah, I'll do it like this. I'll use the method call in case we want to change it later. -1, or index is great or less than 0, so that if the index is negative, because that doesn't exist, throw new index out of bounds exception. All right, does that make sense to everyone? Why we would do this? Yeah, okay. So what I'm just doing is I'm checking the index. I'm seeing if the index makes sense. because if the index is outside of the size, or if the index is less than 0, we throw an exception and we make sure that we don't handle that. So now we can even enhance this. We can say we can give it some detail. Size. Yeah, kind of makes sense, right? So then we can say the actual code. We'll start a counter, and it'll help us loop through. We'll have our final data, which we'll be returning. And we'll have our temporary list node, just as Mia said. And we'll start it at the head. And now what we can do is we can do a while loop. So while temp is not null. How does the type E work? Well, the type E is set when you create a list of links. So when you call the list of links constructor, you specify in triangle brackets any kind of object in Java. And then imagine, like when you're in a Word document and you do Control F, Control V, like find and replace. It will replace every E with like that kind of object. So if we do a string, all of the E's will be a string. If we do like any other object, it'll just be whatever kind of object. So we can imagine E as a placeholder for any kind of object. The reason we use it is that you don't want to hard code a list to be a list of strings or ints. You want a list to work with any kind of data. And this is how it's used in all of Java. We haven't seen it yet in class, and we won't be for like weeks. But I think it's a really easy concept, so I'm just trying to introduce it early so that you guys can have some code that's versatile, because you're going to be implementing lists before you learn about generics. But generics are really helpful with lists. So for the sake of making it easier to live your life and reuse code, well, I teach generics really early so that you guys can reuse your code as much as humanly possible. You will have access to the code I'm working on, yeah. So now if we say if the counter is the index, because remember we're working with the counter, we can say output equals temp dot data, get data. And then, oh no, it's called data. And now here we can say temp equals temp.next as part of our while loop. And counter plus plus. Hopefully that makes sense. And then we return the output. Or I guess return the data. Right? Does this kind of loop make sense to you guys? If we use this code in an assignment, can we risk a plagiarism notice? Well, if you straight up copy paste my code directly to the assignment, you'll probably have identical code to other people who also follow the tutorial. I don't think it strictly would count as plagiarism because I am showing you this as part of the instruction of the course, but I would also avoid it because it's never good to even have that come up. Like, you should be, as this is part of Comp 250 and this is something that is directly being taught to you, and since it's not exactly like, this is not code from an assignment, that you'll still have to do some work to, to actually make this work. Is there some way to break out of the loop in the block if that's good practice? It is good practice. You could also just say return. And that's actually probably more elegant. That works too. But yeah, you will probably get a plagiarism notice if other people also do this. I got an alarm that list node is not visible. Yeah, that depends on your bracketing. I might have actually put bad brackets on the GitHub. Just make sure that this structure, if you go to the structure tab in IntelliJ, make sure it looks like this, that you have list node as an inner class of list of links. If you have that, you should be good. I'll keep the structure up on the side here so you guys can see what my structure looks like. It should look like this, where list node is a class inside of linked list. You just change your brackets if it's not like that. Like if it doesn't look like this, make sure that the bracket for list of links opens there and closes at the last line of your code. So everything is inside of the class list of links in this entire project. And then inside of list node, you have just your list node stuff, and list node is inside of list of links. Hopefully, if you have it like that, it should work. So does the get and index make sense for everyone? Oh yeah, this is what. Okay, cool. So can anybody think of how we can do adding? Adding is kind of similar to our last method. It's a very, like all the methods where we loop through our list are quite similar. So could anybody figure out how we can do add? Or actually, even better yet, let's do get last and let's use get last to do add. And actually get last should be private. And the reason I made this one private is I want to be able to. Why do you have to return null? Well, it won't compile unless we have a return that always works. So this return exists in an if condition, right? This return will only happen if the counter is the index. If counter never reaches index, it never returns. But since we have to return something, well, what I'm saying is that if this loop happens and we never get to the index, we just return null. Does that make sense? Hopefully. Yeah. Perfect. And that's actually the reason I had this return statement at the end before. Like the reason I had this return at the end before, it was actually doing identical. Well, what we're saying, temp equals temp.next, then you return temp. For get last node, that's close, but we have to put it in a loop, remember. Because if we have to loop the code to get to the last node if we have a lot of nodes in our linked list. So we have to do our while loop such that we get to the last node, and then we have to return the last node. So what we can do is we can set up the code in a very similar way. We can say, well, we'll say list node e temp is equal to head, and now we can say while temp dot next is not null. Temp equals temp dot next. And then here we can say return temp. Or even here we can say if. Can we just return the data of get? Can't we just return the data at get of size? We can actually do that. That will work. But this is just a different solution in case you don't have a get. How did you type the not equals operation? I just do exclamation mark equals. And then IntelliJ makes it prettier by changing it to that. It's not actually something I'm writing. It's just a setting in IntelliJ you can use to make pretty characters. It's called, here, enable font lignatures. You can see the difference. If I disable it, it looks like this. And if I enable it, it looks pretty. I just like it because, again, it looks pretty. That's why I use it. So return temp. This will work. Another solution for get last node, if we don't want to do this, is that's as Zachar suggested, we can also just do return get size minus 1. Because remember, it starts at 0 and size is the size of it. Oh, but this we want to list nodes, so this won't quite work because I'm doing get last node. So this one will work, but to get the last node, we actually have to do this. Because the reason I'm doing get last node is that I'm getting a node that we can use in add. So here what we can do is we can say get last node. And now can you guess what I have to do? Can you scroll down a bit? The camera heart's part of the code you're working on. Sure. So here in add, what can we do to get last node in order to, add another node to the list by accessing the last node? What do we have to do? I'll give you guys a sec to think about it, and if not, I'll explain it. Close. I'll show you guys that and why it won't work. So dot set next data. Now, you see this is not working. I'm saying what do we have to do to add another node to the linked list if we have the last node? Like given the last node, how do we add data to the linked list? We create a new node, sure, so we can say list node e of new node is equal to new list node data, and then we add its reference to the field of the last node. That's right. So here we can set the next one to new node, and now before we lose track of our size, we also have to do size plus plus, because otherwise we'll lose track of how big our list is. So does this method make sense to everyone? If you have any questions about this one, let me know. And while I wait for you guys to have questions, I will comment it out. So I'll say we create a new node from the data we are given. We go to the last node and change the reference from null to the new node. And here we track our size. So that should be simple enough. Hopefully everybody understands. And we can move on to another one of the methods. So how do we remove the last node? Does anybody have any clue? It's probably similar to adding, right? Yeah, actually, you know what? Remove the reference from the next field of the node before the last node. That's right. And you know, while we're doing this, I think that the person who suggested using the get method for this was onto something good. So what we could do is we can copy this method and do a version which, instead of returning data, will return a node, and we'll make it private. This will help us out because it'll let us get a list node out without having to write the loop over and over again. So we'll say private list node get return temp. So now this, I've just modified the method from before, the get method, or I'll just call it get node, and this will help us. This is the same method as the get method. I'll even copy paste it for you guys in the chat in case you don't want to do the same modifications as me. This does the same thing as the get method, except it returns a node. And I just wanted to do this so I don't have to write the while loop again. So here we can say this dot get last, or I guess get node at size -2 dot set next. And what do we set the next pointer to in order to remove the last node? Null. Exactly, that's right. Because the way we tell a linked list has ended is that the pointer is null. And now we can just do size minus. And we have the functionality of a basic linked list. The only thing we're missing is toString. So how would you guys create a toString method which shows all of the contents of the list? Like, we want to be able to print off every the data inside of every node in the list. So how do we loop through our list is what I'm asking. Can I paste the private method here? I did. I pasted it right above. But I think I might have, I accidentally direct messaged it to somebody. I'll paste it to everyone. Remember, the private method is identical to the public one. I just changed the list node or I just changed the data into a list node. And that's what I did for it. And I'll even create our solution branch right now so that you guys can access this code afterwards. There. Yeah. Where did I change the code? I just threw it in there. What's that index before remove last, before size? Hard to see. Which one are you talking about? In remove last? I said this is my remove last here. I'll paste it into the chat for everyone. If that makes sense to everyone. Oh yeah, you're asking about this, yes. So where it says index here, what it's doing is it's actually telling me what the name of the argument was. So notice that here I have int index. So what IntelliJ does is it tells me the name of the field here. It's useful in case you forget what this is supposed to represent. It's just kind of a helpful trick of IntelliJ. Yeah, so this is This is the remove last method. And now, can anybody think of the toString method? If there is a good way to do it. Otherwise, I can explain it. What the toString is really asking us is how do we iterate through our linked list? Well, we already have a method which iterates through our linked list. Like, we have a way to do it, and that is by using the while loop. So why not, instead of doing this while loop, in our code, it has two methods overwritten. Get index. Will our code remove last know which one to use? Where? We don't have two methods for get index. We have one called get node and one called get. So get returns is public and it returns a value, and get node returns a node and it's private, if that makes sense. So when we're working with get node, it's returning a node. When we're working with get, it's returning a value. So here we can paste our while loop into toString, and we can use a string builder to make our string. So a string builder is like a mutable string. If you remember, strings are immutable. Well, a string builder is like a string, but it's mutable. All right, so we create our string builder, and then we can say, while temp is not null, okay, we'll say temp list node temp equals head. Temp equals null. We don't care about counter equals index. And we don't care about counter. We'll just say sb dot append temp dot data dot toString return sb dot toString. So this is how I would do a toString method for this. Who wants me to explain the code for this in more detail? Or does it make sense to everyone a lot? If it makes sense to everyone, I'll just comment it through and do it. If you want me to spend more time on any particular line of this to make it make more sense, I'm happy to do that. What is the difference between string and string builder? Well, string builder is mutable. Remember, when you create a string, it's immutable. That means to change it, you have to create a new one and then change the reference, like we have to with an array. Whereas a string builder is mutable. Like, it's a string where we can modify its contents, if that makes sense. So here it's create a mutable string. We set our reference to head. We loop through. And then we return. Well, temp.next is not null. Yeah, okay, let's try it. I've got test code already built into the cartel runnable, so let's see if what happens. It might still be bad because I might have done one of my temp.nexts wrong, which is a mistake I make way too much. So yeah, there's a null pointer exception in this. So let's figure out why. Oh yeah, it's because our add method doesn't specify what happens when we have a null head. And this is the problem that we often have with linked lists. It's that we wrote all these good methods, but we never considered what happens when our head is null. Can you paste the string method here, please? Sure, let me do that. There you go. So we have an issue that our list starts with a null head, right? And where do we ever create our head? Well, we don't. So can anybody think of how we can make this list work despite the fact that the head is null? Dummy head. We could do a dummy head, but there's actually a solution that I feel is more elegant that is, well, I don't know if it's more common, less common, or what, but here's what we can do. We can say if this dot is empty, or this dot head equals null. So we can keep a null head. We can just say this dot head is equal to, actually move this down. Okay, sorry. Okay, so now we've got a different method. Instead of using a dummy head, which can be confusing sometimes, what we could also do is this. So we're checking if our list is empty or if it has a null head. And then if it has a null head, we just set the head variable. It's a really simple if statement, but it does let us also not have to worry about things like a dummy head. It just makes our method null safe, and that's a pretty common thing. I usually recommend that whenever you write this kind of method, it should usually be null safe. Because if it's null safe, that means that no matter what, if the field is null, it still doesn't break. So now if we try to run it, we shouldn't have that issue. No, we still do. We have a different issue now. What is wrong here? Well, now we can debug and we can try to figure out what is wrong with our linked list. And this is a great intro to the debugger. So if we put breakpoints on this stuff, we can see what's going on. So here, let's see what's happening. If we run with the debugger, and we give it our name, to put breakpoints, you just click on the side next to your line number. And we're a cop. It just immediately null pointer exceptions. Why is this? Oh, did I just do something stupid here? No. Use list of links. Yeah, you double click in Eclipse, you single click in IntelliJ. It's pretty simple to put breakpoints. But yeah, let's see. This done inventory, and it's crashing on line number 69. Nice. And debug. Oh, that wasn't even the right kind of input. No, it's just exceptioning on me. Let's see, how is this different from my notes? Very strange. Instead of calling toString, let's just call inventory, and let's see. Oh, is my toString not null safe? Okay, I figured out the problem. Sorry. I was being a bit silly here, guys, and I didn't consider a null value in my toString. So I'm looping through here, and I'm setting something to be null. Let's just do if this dot is empty, return. There. Sorry, guys. That was my own stupidity there. I forgot to consider that. We should have it working now. There. Perfect. So now, if we still broke the program, I think his cop was broken. Sorry, it's a bit of a mess right now with this. Robber. All right. Perfect. Now we can buy. And then this is another quick thing we need to change. Sorry, I'm just making sure my code is good before I say anything final to you guys. So now we are a robber, and we have an inventory, and if we buy something. Now you can see our linked list is working in place of the array. What I've done here is, if you remember the previous tutorial, I used a like a resizable array for the client class for the inventory. Does everybody, like, if you've been there before, you remember that? We used kind of an array list. This time we're using a linked list. So you can see the code is a lot shorter. Before, this used to say, like, you know, the big array iteration, if you remember the previous tutorial. Here, I just do a very simple inventory is a list of links, and we add the thing. Hopefully it makes sense to you guys. Does it? And now, if there's any further questions about this, I'm happy to answer them. The reason we were having the problems is I didn't have this line. This caused a crash because we did not consider null when printing. And this is also a good intro to you guys for what happens during the assignments. You see, when we have testers, like the one here, it's testing weird situations. And the list being null when toString is called is one of those weird situations that you're going to want to test for during your assignments. Because it's something that's not super obvious, right? Like when we were writing the code, it wasn't something we immediately thought of. But it's something that's important, and it's important to catch it. Because we have to think about weird times like that. So a tip for getting a better mark on your assignments is always check the really weird cases, like something being null when it shouldn't be, or, you know, an empty list having weird methods called on it that shouldn't normally be called during an empty list. But yeah, otherwise, this should be quite solid. like I can double check the code before I make a final post that everything is exactly as it should be. But I think this one is a relatively solid linked list implementation. So yeah, any questions, anyone? And I've posted it to the solution branch on the GitHub. No, you don't have to re-import the URL. What you have to do if you want to look at the solution is go to in IntelliJ. You can see at the bottom here, we have one that says master and one that says solution. You just go solution, or I guess I'll start on master. So I'll go to master. And then you click the update button. See the blue arrow? Press OK. It's going to update your code to be the latest. And then you go to solution and you click checkout. And I'll show you in Eclipse as well. So here in Eclipse, I've got an old version of this tutorial for, right? It's old as hell. So in here, we can go right click, click team, somewhere here, team, and then pull, and then close, and then right click, and then click team, and then switch to, and then it should say solution as an option. Remote tracking, solution, checkout. Checkout as a new local branch, finish, and there you go. It's a little bit more complicated in Eclipse, but it's still doable. And here you've got this code. If you want to run it, you just run cartel.java. And the robber doesn't work. What criteria are used to grade our assignment? The way the assignment is graded is it has a tester, like a written tester, similar to the cartel class, where it'll try all kinds of different things with your code, and it'll see if it crashes in strange situations. So for example, the linked list class, the way we had it before I fixed toString, would have probably gotten like a mediocre grade, because the toString didn't work when it was empty. But then when we fixed the isEmpty method to return a blank string if it's empty, that actually makes it a better solution. And like that will make the grade you have better because it's accounting for more weird situations. So essentially the way you get a good grade is you make sure that no matter what you throw at your code, everything works properly. And I think later on in the tutorials, when we have maybe less content to cover and more time to cover it, I'll go into detail on how to make a really good debugger, which will make sure that no matter what you throw at your code, it's going to work. Then you right click, you go team, you right click again, you go team, then you go switch to other, then remote tracking, then origin/solution, and then checkout. I know it's really, really complex in Eclipse. It's just Eclipse is not really designed for GitHub use, I guess. Well, I guess it's designed for it. It's designed for it by buffoons. Is the length of our code also considered? No, it's not. You can have code as long or as short as you like, but the efficiency of your code will be considered. So you can write really long code that works efficiently and you'll be good. Or you can write really short code and it's bad. Is there two pools which to choose? Do you mean from the GitHub? Yeah, there's solution and there's master. Master is the blank one and solution is the solution. How do you do the same thing for IntelliJ? IntelliJ is a lot easier. See the blue arrow at the top there? Click the blue arrow, press OK. And then at the bottom, you see here it says master or solution, depending on which one you're on. So you just click on where it says master at the bottom, and then you should have remote branches solution available. You click on solution, you click checkout. It's way simpler. So here I'm on master, and at the bottom I have master here, and then I click here, and then I click solution and checkout. It make sense? Okay, awesome. So yeah, that's how you go between master and solution. I might update solution later in case I figured out that I did something wrong. It's possible I might have got like one of the temp.nexts when I actually meant to do like a temp.next. Like I might have done temp equals null instead of temp.next equals null. It's a really common mistake. But I'll post a very good, robust solution that I will fully check before we're through. When you're writing linked lists, a really, really common mistake that people make is putting like temp. Here instead of putting temp.next, like putting temp. And that mistake is so common that I probably made it during this tutorial, and I didn't even notice. just because it's a bit hard to keep track of mentally. So those can be debugged with the breakpoint debugger, and I'll make sure to test this thoroughly eventually before I send it over. And well, I've already sent it over, but I'll update it with a better tested version later on. Maybe later today or tomorrow I'll get a really good version, and I'll update you guys on Monday about that. So if that's everything, that should be good for today. If anybody has any questions, I'm happy to answer them now. Otherwise, we can wrap up. So I'll give you guys a bit of time to ask questions, and until then, yeah. Well, the file is the same as before. It should just update your list of links.java. It shouldn't, it's the same file you're working on before. It's just a different version of the same file. Hi, can you show how to make UML diagram in Eclipse? I don't know how to make a UML diagram in Eclipse because there's no built-in function for it. It's a plugin you have to download. I think one of the students did mention a plugin you could use for that, but I'm not aware of it. I don't really use Eclipse very much, and I don't know what you could use to make UML diagrams. What I recommend is just using IntelliJ for it. In IntelliJ, it's as simple as diagrams, show diagram, and you're done. Well, that's modules, but no, we want diagrams, show diagram, Java class diagram, and you're done. You got a diagram in IntelliJ. In Eclipse, there's no easy way to do it. You can't just show a diagram here, but you can get a plugin which does it. Yeah, I don't think there's no, there's no way that I know of built into Eclipse that you can do that. So yeah, that's just one of those things you might want to do in a different IDE. Is there any other questions? What did you use to create the intro? I just used After Effects from Adobe. It's a bad program that I don't recommend. It crashes a lot, but it works. All right. If there are no further questions, I will be wrapping up in about a minute, and otherwise, well, welcome to ask. All right, yeah, thank you guys very much. All right, see ya.